welcome to the 65th virtual UNISEC-Global meeting. The theme of today's meeting is exoplanet, and we are very lucky to have with us 4 experts who will be guiding us through this fascinating topic. So before introducing the 4 experts, I'd like to briefly say a few words about exoplanets and why we decided to host this meeting on the theme of exoplanets. So I think many of us have already heard of exoplanets, but it's still helpful to have a short reminder of actually what is an exoplanet. So an exoplanet is a planet which orbits a star other than the sun. So in other words, we're talking about planets that are outside our solar system. The word exoplanet is actually quite a new word. It was invented in the early 1990s, and the field of exoplanet research as a whole is also quite new and fresh and exciting. So I don't know what you think about when you think about exoplanets, but for me, I think about strange names. So for example, TRAPPIST-1e or HD 189733b, and it still feels a little bit mysterious to me. So we want to understand a bit more about why we wanted to focus on exoplanets, why now in 2026, and why is this relevant for UNISEC? So first of all, why focus on exoplanets? So I think there are 3 reasons we can pick up regarding this question. The first is that by studying exoplanets, we're really pushing forward new frontiers in science. So let's think about what we have to do to capture data on an exoplanet. So we're looking at a very dim, not very bright object, which is potentially several light years away around another star. So clearly, if we want to get data on this object, we need to have very sophisticated instruments. We need quite an impressive data analysis technique. So potentially what the methods that we're going to develop for this process are going to be applicable to many other areas of astronomy and science as well. In terms of engineering, if we want to capture data on exoplanets from a spacecraft, we need a relatively advanced spacecraft. Or we could potentially use a less advanced one with a very ingenious method. And actually, this is the topic of one of the of 2 of the presenters who are going to be speaking today, how we can use relatively simple university satellites for exoplanet missions. So that's quite exciting. And then in terms of value for society, exoplanets can potentially have spin-off applications. So maybe some of you already know this, but cameras typically use, or some cameras use CCD sensors. And these were actually a spin-off from astronomy. So by studying exoplanets, we can create benefits in other areas of society as well. So second question is why now? So why study exoplanets in 2026? And I think so this graph illustrates why we're at a very interesting point in the history of exoplanet research. So until now, the main focus has been on developing detection methods for exoplanets. And you can see we've been quite successful. So we have already around 6,000 exoplanets that have been discovered. And so now we're experiencing a paradigm change. So we can detect exoplanets. So detection is effectively handled. But now what we're trying to focus on is characterization. So for example, can we obtain data on surface chemistry or atmospheric properties around exoplanets? So these are some of the more recent questions that are being asked in this field of research. And then finally, so why do we want to talk about exoplanets in the UNISEC community? So to answer this question, I think it's helpful to remember what is the vision of UNISEC. So the UNISEC vision is, by the end of 2030, let's create a world where university students can participate in practical space projects in all countries. And I think this topic of exoplanets really embodies the relatively sophisticated things we can do and the impact we can have within the university community, in this case, on science. So in order to obtain data on exoplanets, we need quite sophisticated instruments. We need to equip them on board a spacecraft that will be launched and controlled in space. And we need to ensure that the benefits are also flowing down to society. So by studying how exoplanet research can be done on board university-built spacecraft, this is quite a useful case study that may also be applicable for your space projects in for other applications as well. So navigating us through the topic of exoplanets, we are very fortunate to have with us 4 distinguished experts. We have Dr. Elizabeth Tasker, who is an astrophysicist and science communicator at ISAS-JAXA. So in addition to her role in promoting international outreach, Dr. Tasker is also doing research on formation of stars and planets using simulations. Dr. Yosuke Yamashiki is a professor in Kyoto University He is an expert in water resource and water environment engineering. And in addition, he is conducting research on habitability of exoplanets using the ExoKyoto tool, which Dr. Yamashiki will introduce later. Our third speaker is Dr. Taro Matsuo from Osaka University. He is an astronomer and astrobiologist. He serves as professor at Osaka University, and his research focus is on elucidating mechanisms by which life forms. And last but not least, Dr. Satoshi Ikari is an associate professor at the University of Tokyo. He is an expert in spaceflight dynamics and control. And together with Dr. Matsuo, Dr. Ikari is developing a formation-flying satellite mission for exoplanet imaging using small spacecraft developed by universities. So this is a very exciting and novel space project, which is being led within the UNISEC community. So we're really fortunate and grateful that our four experts can share insights with all of us today. So after that short introduction, I'd like to move to the main part of today's meeting, which will be the presentations. So I'd like to welcome our first speaker, Dr. Elizabeth Tasker, to deliver her talk titled Searching for Other Worlds, What Do We Know About Exoplanets? So Dr. Tasker, when you're ready, please begin your presentation.